All right, so mentioned before, this is how we generate the electricity, right? And as the reaction proceeds, zinc 2 plus is built up on the left side, right? We have more zinc on the left side, left solution, and the copper 2 plus receive an electron and start depositing on the copper electrode. Okay, if this keeps happening, what can happen is, well, the difference in electrode potential between these two solutions will be lower, lower, and lower. And eventually, the electrode potential of the two solutions will be equal, and that's when the reaction stops. We lose all the power, all the electricity. Okay, if you want to keep this reaction happening, so we need a salt bridge. All right, it's really, really important. All right, I'm going to ask you what is the purpose of the salt bridge on the exam. That's it. I'm not going to ask you anything more than that. Okay, so we need a salt bridge that contain an inert electrolyte solution or spectator ions. Basically, they don't do anything. All right. So on the left, there are two purposes of using the salt bridge. One, to complete the circuit. We need to have salt bridge at the beginning, but I didn't put in here because it's just too many things in here. What's going on? Okay. So we need a salt bridge to complete the circuit. That's number one. Always have salt bridge. Okay. Number two, to balance the ions in the two solutions. All right. So let's take a look at the electrolyte that commonly used first. So we have either potassium nitrate or ammonium chloride, something that doesn't do any reaction in here. Okay, any positive, negative charge work. All right, but these are the common ones, and it's cheap, really cheap. All right. So let's see. This is how salt bridge keep the reaction going. On the left side, so zinc undergo oxidation reaction, becomes zinc ion. So we have more and more zinc ion floating around. Okay, when the zinc 2 is building up on the anode solution, the negative charge become balanced out. So if you use potassium nitrate, nitrate is going to come down. If you use ammonium chloride, chloride is going to come down. All right, into the solution to toward an anode to retain the electrode potential. Okay, so balance out all the zinc basically. On the right side, so we're losing copper 2, so because copper 2 will become copper deposit on the copper electrode. So we're losing the positive charge. In this case, you can guess now the positive ion, either potassium or ammonium, whatever you use, will come down to replenish the positive charge in this solution, keep the electrode potential of these two high, and the reaction is still going. Okay? All right, concept test. Which of these is or are functions of a salt bridge in an electrochemical cell? One, it connects the two half reaction to complete the circuit. Yes, this one for sure. Okay, it forces the electron to travel. Forces. No, we don't talk about forces, right? No, forces electron. No, electrons move by itself already because the different in the electro potential. So not that. It does not allow migration of ions between two solutions. Well, the two solutions are separate. No, it permits the charges to stay unbalanced in the two half cell. No, we put the salt bridge to balance the charge. No, no, not D. Yeah. And E, it balances the charge of electrolytes in the two half reactions. So, yep, that's it. Balance out the charge. Okay. All right. So your job about galvanic cell is to be able to read and identify the electron flow, flow from the left to right or the right to left. Let's look at on the next video.